Let me, yes. So this is the introduction from Stefan, Julia, myself to this Alpha S 2022 workshop that will take place during the week. As a starter, this Alpha S workshop is the fourth of what now has become a series of workshops on the topic. There was a first one organized in Munich 11 years ago, follow up, but another one at CERN, 2015. Then we had one at Trento here 3 years ago. And then this one here with the link to the agenda is the one we are starting right now. This is a copy and paste from our motivation. The main scientific goal of the workshop is to bring together the current best experts in alpha S determinations, both experimental and theoretical, to discuss and understand all the alpha S extraction methods, and to analyze where we are, what the state of the art is, and what are the improvements expected, and also resolve any discrepancies and discuss averaging and so on and so forth. So if you basically the workshop is organized along the 7 categories of observables from which alpha S is determined. So if you check the PDG today, the whole average is determined by comparing data to theoretical calculations at NNLO or beyond and 3LO accuracy via different observables, and then bringing them together at the Z reference mass. So the 7 group of observables that enter into the world average today are tau lepton decays, quarkonia decays, lattice QCD, comparing lattice calculations to perturbative QCD calculations. And here the data comes from the masses and decay factors for hadrons in the real world. Then deep inelastic and parton densities. Then we have hadronic final states in E plus E minus. We have Z decays, and also we have hadronic final states at colliders. For example, the TT bar cross section, also the total Z and W boson cross section was incorporated last year. So all these measurements bring together this result, 0.1179, with basically 0.85% uncertainty. So alpha S is the least well-known of all interaction couplings, and that's already a motivation to study the detail and to see how we can make progress beyond the current state of the art. So what we did is to organize basically the sessions along these topics in 4 days. So today is devoted mostly to lattice QCD, tomorrow to DIS and PDF, and then also hadronic final states at the LHC. Wednesday it's mostly E plus E minus final states plus a few leftovers. We had to arrange different availability of people, so not everybody could be present at and the program is a bit dense, so we had to move some talks to Wednesday afternoon. And then Thursday afternoon is devoted to tau lepton decays. And last but not least, on Friday we will discuss the average of all values. Then the main outcome of this workshop is a white paper, and we will discuss this rapidly now. This is the Snowmass 22 exercise, and I will tell you where it is next. So all mornings, the idea is that all mornings, each one of us during the week works mornings in the European time, of course. We work on our own contribution. I will point you now to the link where you can upload your text. And then we have also topical discussions at the end of each day, the last half an hour, where we will discuss any issue regarding that has not been discussed after each individual presentation. And then Friday afternoon if needed too. So each talk has an indicative 20 minutes plus 10 minutes allocated time, but our goal is to have as really a truly working discussion meeting. So if you have questions during the presentation, you can ask them. And then we will try to stick to this 30 minutes per talk, including discussion, but we won't be very strict on this. I mean, if there is an interesting discussion, we will not stop it. Of course, however, we have to keep in mind the coffee breaks at each ET star, as well as at the end of the day, because we have to, people locally have to go for dinner, and the center has to close also. So Stefan has set up a CERN Mattermost channel to keep minutes, and also if you want to ask questions or post comments, you can do it there. So you have the link here, so you can click and you can reply. But mostly will be used by Stefan by taking notes of each talk that will help us to make a summary of the white paper. So now let's go to this. What is this Snowmass 22 exercise? I don't know if you are familiar with this, but the American Physical Society, the Division of Particles and Fields, every about 10 years, does a community exercise where it discusses the vision for the future of particle physics in the US and international partners, where the priorities are, what are the most important questions, what will be, this decides basically it's a very important thing because it decides finally the investment of the particle physics community in the US into the different international projects. So the Snowmass 22, I mean, this was started Snowmass 20, but with the pandemic has been extended over 2 years now, and this year will be closed. It's organized into several frontiers, and we are part of the Energy Frontier Group, basically colliders, and in particular in the working group or topical group called Precision QCD. And you have here a link to all the presentations in this work, in this group. The conveners of this group made a call of letters of intent in 2020 for documents to be incorporated into a topical report on precision QCD, and there were 4 letters of intents related to Alpha S, and I was asked to collect all these letters of intents and provide a dedicated white paper. So since together with Julia and Stefan, we were planning already to organize this workshop. So we decided to meet, not just to present the current state of the art, but also to write this document together as a community. The hard deadline is March 15, so in one month and a half. And if we do not submit by then we are out. That's really a hard deadline. So what are the main goals of this white paper? So we want that each contributor and co-authors in this workshop provides 1 to 3 pages. I mean, at least 1 page. I mean, if it is longer, we won't be cutting it, but try to be within this. So it's really a summary with the relevant text, tables, figures, and bibliographical information where the interested reader can go and check for the details. So provide basically a summary of your work, addressing the following questions mainly. So the main questions we want to address is what is the current state of the art of your favorite alpha S extraction method, and what is the ultimate theoretical and experimental precision that we can achieve, and how do we achieve it? So in theory, this relates to discussing higher order corrections, including mixed QCD electrolytic corrections, non-perturbative corrections, new techniques, and we would like to hear from you your personal wish list, in terms of data and theory developments needed in the next 10 years to reach, say, a permille ultimate precision in your extraction method, if possible. The same goes for the experiment. What can we do to reduce the current systematic and statistical uncertainties with current and future machines? Are there any new observables? And again, your wish list. So for this, you have a document here in Overleaf. This is a common effort by all of us. So you can just click. I will click on it at the end when I quit from my slides to show you rapidly in 1 second how we will work together on this. The idea is that you click here and you start editing the text, your section, and you put your bibliography, your tables, your figures, your text. Ideally during the week, and by all means by the end of the month, because we don't need the 3 of us. We need to at least 1 2 weeks to put things together and streamline things. Okay, so let me just click on this. If you click on this, let me stop sharing and let me share my browser. Let me see 1 second, just to show you the Overleaf document. I don't know if you see it. So this is my browser. If you click on the link I provided to you, so you see it here. The title right now is The Strong Coupling, State of the Art and the Decade Ahead, Snowmass 2022 White Paper. You put your name here, your institution, and then you go, and if you're a lattice practitioner here, you add a subsection here with your title and your authors, and you write your text. And then to compile, you click here. I don't know if you're familiar, it's very easy, Overleaf. You click on Alpha S white paper, you click on recompile, and any changes you've made automatically get compiled, and you can check. So voila, that's the idea.